Howdy! In this video, we're going to prove this trig identity, which says 2 tangent x secant x is equal to 1 over 1 minus sine x minus 1 over 1 plus sine x. So there's probably many ways to do this. You could start with the left-hand side here and make it look like the right-hand side, or you can start with the right-hand side and make it look like the left-hand side. I think it's easier to start with the one that looks a little bit more detailed and complex, which in this one would be the right-hand side. So starting with my right-hand side, I'm going to rewrite it first without changing anything yet. Just 1 over 1 minus sine of x minus 1 over 1 plus sine of x. So we're going to try to turn that into 2 times tangent times secant. Notice there's no difference of two fractions on the left, so we probably need to subtract the fractions. So to do that, we need to get a common denominator. So what is the common denominator? Well, 1 and sine x are common terms, but they are not common factors, and there's no way to make them into common factors. So we're just kind of multiply those by each other. So the first fraction, 1 over 1 minus sine of x, we're going to multiply that by the other denominator over itself. Let's add parentheses around 1 minus sine x and multiply that by 1 plus sine of x over 1 plus sine of x. All right, now what we're going to do is try to hopefully simplify this, right, next. But first, we still have to subtract that other fraction. Let's zoom out a little. This is a little bit tight. So we still got to put minus the second fraction, which is 1 over 1 plus sine x. We've also got to multiply that by the other denominator over itself, which is 1 minus sine of x over 1 minus sine of x. So now we can go ahead and subtract the fractions with one big denominator, which is the product of those two factors. I'll just leave it like that right now. 1 minus sine of x times 1 plus sine of x. On top, we have 1 times 1 plus sine x, which would just be 1 plus sine of x, minus 1 times 1 minus sine x. Make sure you put parentheses around that 1 minus sine x because it is being subtracted, so that negative will distribute. Okay, there's a lot we can do here. Hopefully you see some things. If not, you just have to really be willing to try something, okay? We're hoping to turn that, again, kind of keep your eye on the goal. We're hoping to turn it into 2 tangent x secant x, right? Okay, so down here in the denominator, that's a question. Usually I do not multiply out denominators. I leave them factored, but this one's special. Why? Because if we FOIL that out, those are conjugates of each other, which means when we FOIL it out, the outside term is positive sine x, the inside term is negative sine x. Those cancel, right? So I'm going to go ahead and do that. So the first term is 1. 1 times 1 is 1. And I just showed the outer and inner terms cancel, so I'm not going to write them. We'll just jump to 1. And then minus sine x times positive sine x is negative sine squared x. And there's a reason I did that, because on the next step, that's going to simplify further. Up top in the numerator, let's go ahead and distribute that negative right here to get negative 1 plus sine x. Now we're trying to turn that into 2 times tangent x times secant x. Okay, well, up top, the 1's do cancel. We have 1 minus 1, and that equates to that. Let's color that. There we go. Okay, so what do we have? Well, on the numerator, we have sine of x plus sine of x. That makes 2 sine of x. And on the denominator, 1 minus sine squared. Hopefully you recognize that is a rearrangement of the Pythagorean identity. So a little scratch work over here on the left. The Pythagorean identity for trig states that sine squared x plus cosine squared x is equal to 1. So what you want to do is start hopefully recognizing rearrangements of that identity, such as 1 minus sine squared. Because if we subtract sine squared x from both sides of that equation, we're left with cosine squared x equals 1 minus sine squared x. Okay, so we can replace, see this denominator right here by 1 minus sine squared x, we can replace it by cosine squared. So all of that is over cosine squared x. How do you know to do that? Well, kind of two reasons. Number one, experience, but number two, it's by looking at what we want. We want to turn it into 2 times tangent x times secant x, and we're pretty close. We've got the 2. We just need to turn this sine over cosine squared into tangent times secant. So we can do that though, because we can split this up. Actually, let's just pull the 2 off to the front. 2 over 1 is 2. 2 times, let's split it up into sine of x over cosine x times 1 over cosine x. Normally, if I was just simplifying, I may have stopped in the prior step, but since we need to turn it into 2 tangent x secant x, got to keep going. But there's only one more step and then we're done, right? So 2 sine x over cosine x, sine x over cosine x is equivalent to tangent of x. So we can rewrite this as 2 times tangent of x, and then also 1 over cosine of x is equal to secant of x. And we are done, because that is now the left-hand side. So we successfully converted the right-hand side into the left-hand side to prove that trig identity with clear steps for every step along the way.